Hi, in this video we are going to work on geometric sequences. In geometric sequences we multiply by a common ratio to get the next term. So it's something like 2, for example, 6, 18 and so on, and you can figure out that if you multiply by 3 you get 6, if you multiply by 3 you get 18 and so on. So like the arithmetic sequences, this is the first term, right? But now instead of the common difference, we have the common ratio, which we denote with R. A geometric sequence can be increasing, like this one, or decreasing, like 1, 1 over 2, 1 over 4, 1 over 8, and so on. You can notice that the common ratio here is 1 over 2, which you multiply to get the next term, right? Or it could be alternating, like 1, negative 2, 4, negative, not 6, 8, and so on, because my common ratio is negative 2. So I multiply by negative 2 each time I want to get the next term. Like the arithmetic sequences, we have a formula for the nth term, which will be a times the common ratio to the power of n minus 1. Now remember the discussion in arithmetic sequences. We were to write a plus n minus 1 times d. The reason is the first term does not include the common difference. The same applies here. The first term does not include the common ratio, therefore the common ratio is here in the second term onwards. So this is the first time we see common ratio multiplied, this is the second time, and so the power of the common ratio must be 1 less than n, right? So this is the formula for the nth term. Let's see some examples. So let's find the 10th and the nth terms of each geometric sequence. The first one will be 3, 6, 12, 24, and so on. Well, we need to write down the first term, which is 3, and the common ratio. For the common ratio, all I have to do is to pick 2 consecutive terms, like these two, for example. You can pick any 2 and write the ratio. 12 over 6 is 2, so the common ratio is 2. So for the 10th term, I go like u sub 10 equals the first term times the common ratio to the power of 10 minus 1, which is 9. So I end up with 1536 if I do the calculation, right? This is the 10th term. For the nth term, I just write 3 times 2 to the power of n minus 1, right? And I can stop here. I don't need further simplification, like, this is 3 times 2 to the power of n and 2 to the power of negative 1. So this must be 3 over 2 to the power of, 3 over 2 times 2 to the power of n. We don't need any of these. This is more than enough. So if I have an alternating geometric sequence, something like 30 minus 15, then 7.5, and so on, right? Well, the first term is 30, and the common ratio, if I just take these two, for example, the common ratio will be minus 15 divided by 30, which will be minus 1 over 2, right? So for the 10th term, I go like 30 times minus 1 over 2 to the power of 9, and I will get minus 30 over 512. So if you try to get this as a decimal, it's going to be a long one. So you can just, simplify this to minus 15 over 256, and that's it. And the nth term will be like 30 times minus 1 over 2 to the power of n minus 1. So this is my nth term. Now this can be further simplified to 15 times 2, which is 30, right? And then I separate minus 1 and the fraction, so it is minus 1 to the power of n minus 1, right? And then when I flip the remaining fraction, which is 1 over 2, if I flip it to 2, that's going to be minus 1 together with n minus 1, and the power rule tells me that I can multiply these, so I end up with 1 minus n. And just because the power is 1 here, now I can just write down, this is minus 1, let's write this to the beginning so that it will tell us that it is an alternating sequence, right, times 15, and I'm going to now write down 2 to the power of, if I add these, I'm going to get 2 minus n. So I can further simplify my nth term like this. Another example. In a geometric sequence, the second term is 4 and the fourth term is 8. Given that r is positive, find the exact value of 11th term. Now remember what exact value means. It means that we are going to end up with a third, right? And we have to keep it that way. We are not going to round a decimal or anything, all right? So now u2, the second term, is 4 and u4 is 8. Now I can write a common ratio here because this is going to be a times r, this is going to be a times r cubed, right? So if I write this ratio like this, it's going to be 8 over 4. So I will simplify a's, and I'm going to end up here after simplification r squared, which is going to be 2. Now if r squared is 2, I'm going to end up r being plus or minus root 2, but just because r is given to be positive, I'm going to end up with r equals positive root 2, right? Now u11, it is a times r to the power of 10. Now I know r, but I don't know a. So let's calculate a. I can use this, for example. So u2 is 4, which is a times root 2, because r is root 2. So if I divide both sides by root 2, I'm going to end up a being 4 over root 2. And if I rationalize the denominator, I'll end up with 4 root 2 over 2, which is basically 2 root 2. So this is what I'm going to write here. u11 will be 2 root 2 times r, which is root 2 to the power of 10. If I calculate this, I'll get 64 root 2 as the 11th term. Another example. So we are given the first 3 terms of a geometric sequence, and we have to find the possible values of x and then the 8th term. So first of all, just because I know that the first term is 3, I need to find the common ratio, right? So to find it, I'm going to compare these two, and then I'm going to compare these two. So this must give me the same common ratio. So I go like x over 3 is the same as x plus 6 over x. So because I compared this to this, and then I compared this to this, it must be the same common ratio. So if I cross multiply, I get x squared equals 3x plus 18, right? So this will give me a quadratic equation to solve, which I'll get x to be 6 and minus 3. Now, just because the terms are all positive, I shouldn't be choosing this. I should be choosing this x value. And then the sequence will become 3, 6, and 6 plus 6, 12, and so on, right? And then from here, I can calculate the common ratio being 6 over 3, which is 2. Now, I can now start with finding the 8th term. Let's do it here. u8 must be a times r to the power of 7. Well, I know a, I know r. A is 3, r is 2, so it's going to be 2 to the power of 7, which will give me 384 as the 8th term. So now let's add a part C here. Find the first term that exceeds 1 million. So we are going to use the nth term formula. So we are looking for the value of n, right? So it's going to be 3 times 2 to the power of n minus 1, which will be bigger than 1 million, right? So let's solve this inequality. I'll start with dividing both sides by 3. So I'm going to have 2 to the power of n minus 1 greater than 1 million over 3. And then I'm going to go log in base 2 of 2 to the power of n minus 1 is bigger than log in base 2 of 1 million divided by 3, right? And then I'll go on saying that just because this is 1, if I take it to the front as a power, I'm going to end up with n minus 1 is greater than log. Now you see, I don't calculate this until the last minute because I know that it's going to be a decimal. So I'm going to add 1 to both sides. So n will be greater than 1 plus log in base 2 of 1 million over 3. Now, if I calculate this, I'll get n is greater than 19.34 and so on, which means n must be equal to 20. So the 20th term will be the first term that will exceed 1 million. So if we check this out, we end up with 1,572,864. So yes, this is bigger than 1 million for sure. So basically the geometric sequences are pretty much it. There are different types of questions, but if you stick to the formulas and the idea of finding common ratio and using the first term with it, I think you can solve all those different types. Thanks for watching.